All right, example 4. And we're going to do this one again, but we've just talked about the tangent identities. And so now we're going to use those tangent identities with this problem. So we're going to use the sum and difference identity for tangent to find the exact value of tangent 285 degrees. And again, what we're doing is we're either adding or subtracting numbers that are from a unit circle that we actually can give us that value of 285. So the best thing to do is go ahead and find two numbers that maybe add, because that'll make it a little bit easier to work with. And hopefully one of them is in the first quadrant, so that makes it a little bit easier even to work with there. So let's just think about this. Tangent, we know, just trying to figure out values here that we can use. We know 45's in the first quadrant, 30's in the first quadrant, 60's in the first quadrant. So maybe if we can do 280, not 280, sorry, we can do, let's see, we have 150 plus 60 wouldn't work. Just throwing around some ideas or whatever. But one thing I know will work for it is if we do 240 plus 45. And both of those, 45 is in the first quadrant, so that helps out. And sometimes it might not always be first quadrant that they will add to give you that answer, or subtract to give you that answer, but it's always good if you can get one. So here we are using our sum because we're doing 240 plus 45 to give us 285. 240 plus 45 equals 185. So we're going to use this and find our values. So we're going to use our identity here for tangent, sum identity for tangent. So we're going to do 240 plus tangent 45. Remember again, the plus comes on top with it, and then the minus is on the bottom, or subtraction is on the bottom for the sum, sorry. And then here we have tangent 240 times tangent 45. Now again with these, again like I've said before, you have to know these values when it comes to sine and cosine, tangent, and all that great stuff. So when we look at each one of these, I'm again expecting you to know them already. So for tangent 240, you should get the square root of 3. All right, and then we're going to add the tangent of 45 degrees, which is 1, all divided by 1 minus, and again, we have the values already, square root of 3 times 1. We shouldn't make it that hard because we should be able to work things out and everything. All right, so here, oops, sorry guys, I didn't mean to move that screen. All right, so here, if we simplify everything down, we know we get, oh, it didn't go back, it didn't stay down. Stay. All right. We get the square root of 3 plus 1 over 1 minus the square root of 3. All right, now, this is one of those things that I've talked about already in class for trying to figure out trig identities and making trig identities to simplified trig identities there, or verifying them. We said we're going to multiply by the conjugate. I'm going to write multiply by the conjugate. Conjugate. I think I spelled that right. I might have spelled it wrong, guys. I'm sorry. Conjugate. Something like that. I'll fix it later on. But the conjugate. So when we do that, what we're doing is we're going to take your denominator, because we can't have a radical in denominator, and we're trying to simplify it down. We'll do the same denominator, but change that one sign in the middle. Change the one sign that's in the middle there. Oops, sorry. And then again, because we're multiplying it by 1, so it doesn't change the value of the function, but it changes the actual numbers in the function, but not the value of the function, because we're multiplying by the same thing. So that's considered times 1. So we have to multiply everything out. So we FOIL it, and then we do box method, whichever one you learned. And so if we do that part here, we get the numerator, if we FOIL that out, we get square root of 3, and then we do square root of 3 times square root of 3, sorry, my fault, sorry about that. I lost my train of thought. And then we do 1 times 1, which is 1, and then 1 times the square root of 3, which is square root of 3. Sorry, I'm sorry, this is supposed to be a plus right there. So square root of 3 times square root of 3 is a positive 3. Right, and then on the bottom of the fraction, we go ahead and multiply it out again with FOIL or box method, whichever one you learned. And when that happens, you get rid of your middle numbers. Sorry, positive square root of 3, negative square root of 3, negative square root of 3 is what we have here. And then we have a negative 3 on the bottom. So if you FOIL it out, do all that, or box method, whichever one you learned. We already know here that when it comes to your denominator, these two cancel out. We know this is an understood 1 here and understood 1 here. So in our numerator, we get 2 square roots of 3 plus 4, because 3 plus 1 is 4, and then 1 plus 1 is 2. And then on the bottom, we have 1 minus 3, which is a negative 2. And again, remembering, like we talked about before with our fractions, we can rewrite things if they have a common denominator like this. And so our final answer would be negative square root of 3 minus 2. Or you can switch it around, whichever way, it doesn't matter. But again, we finally multiplied by the conjugate so everybody can see what I was talking about before. And so now, that's your final answer. All right, so it's not bad at all. But we got this, we can do this.